Trapezoids are the last quadrilaterals we'll look at, and in Lesson 8.6 you will recognize and apply the properties of trapezoids and solve problems involving the medians of trapezoids. How are trapezoids used in architecture? The Washington Monument in Washington, D.C. is an obelisk made of white marble. The width of the base is longer than the width of the at the top. Each face of the monument is an example of a trapezoid. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called bases. The base angles are formed by a base and one of the legs. The non-parallel sides are called legs. If the legs are congruent, then the trapezoid is an isosceles trapezoid. Theorems 8.18 and 8.19 describe two characteristics of isosceles trapezoids. Both pairs of the base angles of an isosceles trapezoid are congruent, and the diagonals of an isosceles trapezoid are congruent. So they obviously do not bisect each other like we did in a parallelogram. They're just AC is the same as DB. The sides of a picture frame appear to be two adjacent trapezoids. Determine if they are isosceles trapezoids. I hope the angles are showing up pretty well, and you can imagine that the sides would also be congruent, but definitely the base angles are congruent. So yes, and the reason is base angles are congruent. The top of this workstation appears to be two adjacent trapezoids. Determine if they are isosceles trapezoids. I'm not very creative here because the answer is again yes, base angles are congruent. ABCD is a quadrilateral with the vertices given. Verify it's a trapezoid. They were nice enough to graph it for us, so I'm going to use their graph to get our slopes rather than using the slope formula. Slope is rise over run. So we went up 4 over, and I just did BC first for no apparent reason. May as well keep going around since I started there. CD, it's going up only 1 and over 4. So rise over run there was 1 over 4. It's not perpendicular, it's not negative reciprocals. DA, my rise, it's going down in my run. So I went down 3 and over 3, and it was down. So rise over run, negative 3 over 3 is going to be negative 1. And finally, AB, where I intended to start. My rise, I'm going down 2, and my, actually up 2, moving from left to right. And my run, I went over 8. So up 2 over 8, it reduces to 1/4. So my opposite sides are parallel. One pair is parallel, so it is a trapezoid. If we don't want them both parallel, that would be a parallelogram. And we already counted squares, so I'm not going to use the distance formula either. We'll just use Pythagorean theorem. 1 squared plus 4 squared is going to be 1 plus 16 is square root of 17. And for AD, we've got 3 squared plus 3 squared. We know it's a trapezoid. Is it an isosceles trapezoid? My legs are not the same, so no. And explain legs not congruent. The segment that joins the midpoints of the legs of a trapezoid is the median. The median of a trapezoid is also called a midsegment. Recall from lesson 6.4 that the midsegment of a triangle is the segment joining the midpoints of two sides. The median of a trapezoid has the same properties as a midsegment of a triangle. You can construct a median of trapezoid using a compass and straight edge or GeoGebra like we did. The word median means middle. The median of a trapezoid is a segment that is parallel to and equidistant from each base. The median of a trapezoid is parallel to the bases, and its measure is 1/2 the sum of the measures of the bases, or the average. DEFG is an isosceles trapezoid with median MN, so that means these are equal. Find DG if EF is 20 and MN is 30. And they made it a little bit more interesting for our first time. We're going to add 20 plus the part we don't know, divide by 2, and it has to equal 30. Little algebra, so to undo divide by 2, we're going to multiply both sides by 2. Times 2 divided by 2 cancels out. So we have 20 plus x equals 60. Subtract 20 from both sides, and we have x is 40, which is the name I gave for the length of DG. DEFG is an isosceles trapezoid with median MN. Find the measure of angle 1, 2, 3, and 4 if the measure of angle 1 is 3x plus 5, and the measure of angle 3 is 6x minus 5. Well, with parallel lines, we remember that consecutive interior angles are supplementary. So 3x plus 5 plus 6x minus 5 have to add up to 180. Can combine our like terms. 9x, oh, nice, the 5's go away. And divide by 9, and x equals 20. If x is 20, we can substitute back in to get the measure of angle 1. 3 times 20 is 60, plus 5 is 65. And then angle 2, it's an isosceles trapezoid, so our base angles are congruent. So it's also going to be 65. And then for angle 3, we could subtract 180 minus 65, or maybe we'll just substitute back in. So 20 times 60 is 120, minus 5 is 115. And 115 plus 65 is 180, so that's good to know. And that is going to be the same as the measure of angle 4, because again it's an isosceles trapezoid. So there are our 4 angles. An isosceles trapezoid, both pairs of base angles are congruent and the diagonals are congruent. The median of a trapezoid is parallel to the bases, and its measure is 1/2 the sum of the measure of its bases.